No matter how well we understand how a single droplet of water is formed in the laboratory, we cannot predict how countless droplets form clouds that substantially affect the Earth's climate. And although we can accurately characterize a single neuron's impulse, we do not yet understand how billions of them form a single thought. In such systems, animate or inanimate, processes of self-organization are at work. Many interacting parts organize themselves independently, without external control, into a complex whole. At our institute, we explore the mechanisms underlying these processes in order to gain a detailed understanding of complex systems. Also, the major challenges of the 21st century, from climate change and economic crisis to problems in energy supply and transport, are closely linked to these scientific questions. Without a deep understanding of dynamics and self-organization in complex and highly networked systems, we cannot face these challenges. With our basic research, not only do we want to deepen our understanding of nature, but also want to contribute to a sustainable existence on this planet.